So guys, real quick. If you're not doing this, you don't make any sense to me. If you integrate something and you have just a couple moments, real quick, start to do the derivative of it, right? What happens if I take the answer to an integral and I take its derivative? What should happen? If I did the integral correctly, so if I integrate a function and I get an answer,
Then you should be able
if
to
I
do
take
the
that
derivative.
answer's derivative, what should I get?
The derivative of the antiderivative.
The original function, yes, that's integrals are antiderivatives. Do you agree that derivatives are easier than integrals? Yes? So you don't have to do it all the way. Very often, if you make a really basic mistake and you just take a second and start to do the derivative, you'll go, oh, wait a minute, that's not gonna work. I must have done something wrong. Yes? You have a built-in way to check yourself before you wreck yourself. So, I mean, that's awesome. That doesn't happen very often in mathematics, where you have a very clear way to check what you're doing. Okay, maybe. So, I'm sorry, Ezekiel, what you got?
Right. Well, I suppose going with 3C to begin with.
3C on the test. Don't worry, I'll bring these back up.
I haven't had it on there. Darn it.
All right, so 3C. What was 3C? 3C. Oh! Sorry. A really huge general approach to integration. If there is a part of your integral, does anyone know how to do this? The most common answer I get is 1 over x plus c, but what did that person do if they say 1 over x? They did the opposite of what that's asking, correct? Let me just cut to the chase. Ain't a single person in here that could do that unless you've been looking into chapter 7. Because this is the first thing you learn in Calc 2 is how to handle this interval. It is beyond us. If I see a natural log inside of an interval, I'm like, I'm making that shit u. Yes? Because is the derivative difficult of a natural log? No. You with me? Okay. So, everybody is 3C. That's the one you're talking about, right, Ezekiel? Let me see. I'm pretty sure everybody's 3C had a natural log in it.
Mhm.
Yeah. So everybody had something that looked like 11 natural log of y minus 7 over, I don't know. What you got, Jeff? 3y minus 21 dy. And it was going from something that doesn't even matter. It was going from 8 to e plus 7, because I am a jackass. Now, real quick, can anyone see why I made one of the limits e plus 7?
It gets rid of the ln.
Yeah, e plus 7 minus 7 is e. Natural log of e is 1. Now, I can't do that directly right now, can I? I can't just plug that shit in. Yes? One major thing, before you start plugging these in, make sure you actually integrate it. I still have a few people just starting to plug stuff in. I'm like, no. This isn't just function notation. You got to integrate before you plug that stuff in, yes? So, I see a natural log inside of this interval, and I don't have a clue how to integrate natural log because I haven't taken Calc 2 yet, because I'm just in Calc 1. Yes? I'm talking like I'm one of you guys. So what am I going to let u equal? I don't like the fact there's an ln inside my integral. I'd like to replace it.
Use ln y.
So I'm going to let u equal ln of y minus 7. Another reason I want to do this, where else is my variable in the integral? On the bottom. And what is the derivative of the ln? What does it do to the variable? Puts it on the
Top.
bottom, yes? The derivative of a natural log of y is 1 over y, yes? Do you start to see, you have got to see the logic in the problem. Why do I pick a certain piece of it? I can see the reasons. I don't know what the integral of ln is, so I can't have an ln inside my integral. I see variables on the bottom, and I see ln's. Oh, derivative of ln puts variables on the bottom. This is going to, I want to let u equal that then. What's du?
Y, 1 over y minus 7.
Dx.
D, D, yeah, x,
dy.
or dy.
There it is. Now I heard some people murmuring out there. You're starting to look ahead. Do I have this in there? I actually do. I just have what extra?
You have to factor
I have an extra factor of
3.
I have an extra factor of 3 on the bottom. Yes. So what can I take out of my integral?
Your 3.
I could take 1 over 3 out. And then aren't I left with exactly du? Do you see the path you must take? You have got to think what makes sense to try to let u equal. And the thing is, some of you guys let u equal something and then you do it and then you give up. You don't even come back to it. I'm like, now you know what u can't be. Now you're one step closer to doing the damn problem. Go back and pick something else. Yes? Unless you feel pressed for time, in which case come back to it later and then try some rope and try something else. You already know what won't work. Try something else. Maybe. Yes?
You do have d, like where we are right now with it being 1 over y minus 7. And
Yeah.
in the actual problem, you just take out that piece in the actual problem?
Yeah, so I can take 1/3 out. Hell, I can take 11 out too, but let's not worry about it right now. Is everybody cool with that? If I get 3 out of the bottom, I get 1 minus 7. Do I see du? Yes. Could I have taken 11 out also? Yes, that would have been smart. Yes.
So it just becomes a 1 on the bottom instead.
Well, dy over 1 minus 7 is du. So I'm just going to replace all that mess I just circled with du. It doesn't become a 1. It's just part of what du is. So it just gets replaced with du. Okay, maybe. That's as far as I'm going to go. Nobody had that problem, but everybody had that problem. So I'm not going to do any more. You guys know where I'm going. Now, real quick, what's the next thing? Have I replaced? I've gotten everything set up to replace with you, yes? What's still here?
The 8.
These. On my next step, I'm going to replace stuff with you, so I better do what? Figure out what 8 and e plus 7 become, yes? Yes? You guys with me? You got to change everything that was y, you have to change it to you.
Just plug those into the.
We have set up the relationship between u and y. So if y is 8, what's u?
ln 1.
Which is?
ln.
If y is 8, yes? Is y 8 in my integral at some point? Yes. So if y is 8, what's u?
1.
Natural log of 1 is 0.
0.
So my u integral is going to be 0 on the bottom. What if y is e plus 7?
1.
E plus 7 minus 7 is e. Natural log of e is 1. So it'll be 0 to 1. That sounds nice. Yes? Okay, maybe. So when you're doing u sub, you're letting u equal the thing whose derivative is in there. Constants, if I'm missing a constant or I need a constant, that doesn't bother me. I can make that happen. Is that any better? Now I know for that problem it's better. Is it better in general? If I see an ln in my integral in Calc 1, I am letting u equal that damn thing. Because I can't handle the integral of ln. Not yet. Okay. Yes.
Same with 3, but part B. I kept getting a undefined value whenever I try to reevaluate.
Oh yeah. Some of you guys had this thing. You notice I didn't take any points. Was it this?
Yes.
And what I did was, because I have to make several versions of the test, because I love you guys, but I can't trust all of you. I forgot to change the limits. So right there, right off the bat, 0 makes that function undefined. So what I was doing was, as long as you pick the appropriate u, I would give you a bulk of the points. If you also noticed, oh, this makes it undefined, I would give you 4 points. Yeah, so that's why you didn't lose anything.
What number?
This is, now, real quick, this is 3B.
Yes.
Did some of you guys have a secant squared in 3B?
Yes.
You're fine. Some of you guys had a cosecant squared in 3B, yes? You with me? If you try to do a u sub and you try to plug 0 in, you will get undefined. So right there, you can just say this interval can't work. Or at least, as far as you know, Calc 2 also talks about what's called improper intervals, which is where when the limits take it to infinity. But for us right now, you can just stop there. Okay. I didn't do that on purpose. I just created a new problem and forgot to change the limits.
Oh, so that freebie just doesn't work.
Yeah, but I need to see you show me that it's undefined. Yeah.
It was driving me crazy on the test.
I understand. I saw that and it felt so bad. But what can I do? I'm only one little human. Yes. Yeah. Oh, so again, so everybody's 2E had, I don't know, blah, 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 blah. I'm gonna make mine look, let's see if anybody's cool with how mine looks here. So if you look at your 2E, oh, by the way, ooh, 2E is even better than this, but we'll get there. I want to talk directly about this. What's different with your 2E and my 2E?
I have a trig function.
Trig functions, yes, who cares? They're just derivatives, blah, blah, blah. What's the big thing that's missing? So I know what to do. Okay. So I know what to do. Let me make mine better. There, mine's more like yours. Just without the trig. Based on what we just said, what do I want to let u equal? Yeah. For 2 reasons now. 1, it's natural log inside of an interval. 2, it's stuck inside of a 5 to the power, yes? 97% of the time, what do you let u equal? The part that's inside of another function. You guys
Yeah.
see that?
Yeah.
So you guys have ln sine x or ln cosine x, yes? Yes? All right. For those of you playing along, if you choose to do that as u, that's right. Some of you guys just did not take the derivative correctly. What rule has to come to play for natural log of trig function? What rule comes into play if I have natural log of stuff?
Oh, right.
Chain rule. So if you apply the chain rule, you get the thing that's in front of your 5 to them. So here, just to cut to the chase, if I have what would it be, Jeff? It would be this. Somebody have something like that? Yes. So if you let u equal natural log of sine x,
F.
say again?
Must be
Or
F.
Thing isn't like too bad.
Oh
Yeah,
yeah,
we're on
yours
F.
might be out of order. That's right. Different versions, I moved this problem around.
Yeah.
Does everybody have a problem like this? Trig in front of a number to a natural log of a trig? Yes? It's a very Jeff problem. I love it. But again, you have got to be at a point where this problem specifically is just screaming at you what to let u equal. There's 2 reasons for the damn thing. Natural log, which I can't integrate, and it's stuck in the power of a 5. I'm gonna let u equal that shit. Now, some of us did everything perfectly right, but forgot how to integrate like 5 to the u. The derivative of 5 to the u is 5 to the u times natural log of 5. So the integral of 5 to the u is 5 to the u divided by natural log of 5. Because they're opposite operations, yes? Maybe? No? True, Jeff. He hasn't made sense all semester. Why would he start now? So again, the more you know your derivative rules, the more sense integration makes. Because on the first go round, that's all an integral is. We did prove that it ties to area, but an integral by itself is just an antiderivative. Is that okay, or is there a follow-up question? You guys? Some of you guys have natural log of cosine x up there, yes? You guys, yes? Right now, can everybody who didn't get that right, can you let u equal your ln of stuff and then take its derivative? Do it. You got to do it for your corrections anyway if you want to. Even if you're not going to do corrections, can you just do it for me? Can you just do it? So me, I'm going to do this.
ln of sine x is your u. And then 1 over cosine x.
So some of you guys have that, yes? And some of you guys have this. Yes? So take its derivative. Take the derivative of the one that you've got. I'll do both. You got to use what rule again? Chain rule, yeah. So the first step on both of these, what's the derivative of natural log of stuff?
1 over stuff.
1 over stuff. Times the derivative of stuff. What's the derivative of cosine?
Sine. Oh, negative.
Negative sine. And what's the derivative of sine? It's insane. What is sine over cosine? Tangent. For those of you who had this, do you not have a tangent in front? Isn't that now part of du? Over here, what's cosine over sine?
Cotangent.
Cotangent. So you would have been much like me, cotangent x dx is now du. Yes? You guys see that? Some of you guys give up too early because you're like, well, how's this ever going to do it? No, you got to take it all the way out. You've got to take it all the way out. A couple of you did the u right, but then did the derivative wrong, and I agree. Ain't nowhere to go after that shit. And not many of you, thank the gods, but a few of you took the cotangent out or something. Can you do that? Can you take a function of x or x itself out of an integral? Ain't no damn way in hell you can do that shit. Yes? Constants I could do. Now, real quick. So here's what I'm saying. If I had to integrate this, there. Wouldn't it be great if that could be out here? Wouldn't it be great if I could just take this out? Is that integral easy now? Oh, that would be so cool if I could do that, but that doesn't make a damn bit of sense for several reasons. Primarily, the answer I get, its derivative is supposed to be this. Ain't no chance in hell the answer I get here is going to have a derivative equal to this. Yes? That's what I mean by first level. Start to do the derivative of the answer, and then you'll very often you'll see, oh, that's completely wrong. What have I done? More importantly, let me put a constant here. Why is it cool? Why is the 2 okay to come out, and why is this not okay? Well, that's what we want to know, Jeff. Is the 2 ever not a 2? It's always a 2. So it's always a 2. In every term of this infinite sum, it is a 2. So of course I could pull it out. Is x always x? What's the whole idea of this shit? I'm going from something to something, and this means change in x. So is x always the same value? So how can you pull it out if it's not the greatest common factor? It's not the same thing in every term. That's why a constant can come in and out all day long, because it is the same thing. Its name is constant. Variable varies. I can't take it out because it's not the same number in every term. That's basic factoring, yes? Okay. I said that back when we had like this is a limit as of the sum, blah, 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 blah. But it's a good thing to revisit because it's very understandable as a human to just go, oh man, if I just take that out of the way, what I'm left with is easy. Yeah. You get done with the test really fast. Bunch of wrong answers. Maybe. Okay, yes.
Really quick, what was the integral rule for a to the x?
Oh. So real quick, what's the derivative of a to the x?
A to the x ln a.
So it's itself times ln a. So the integral of a to the x, opposite than this, it's itself divided by ln a. Plus c. Since they're opposite operations. So fundamentally, when I take the derivative of a to the x, it doesn't change. It gets multiplied by an adjustment if its base isn't e. So when I integrate, if it doesn't change, if this piece doesn't change when I take the derivative, it can't change when I take the integral. Because all the integral's doing is going back to what was there. But this multiplies by ln a, so this has to divide by ln a because they're opposite operations. Okay. Maybe. Yes? Oh yeah. Did you have tangent or cotangent? Tangent? All right. Now, some of you guys put secant squared x. So that's wrong because secant squared x was the answer if my question was, when would secant squared x be the answer if my question had been derivative? So that's automatically not correct.
What problem is that?
I don't need 2f. Then you're like, my God, who hurt this guy? Why is he taking this shit out of me? But is there a way to rewrite tangent? What's the most fundamental way to rewrite tangent? Sine over cosine. Do you have a function in there whose derivative is in there also?
Yes.
Now be really careful. What's the derivative of sine? Does anyone see how cosine is not truly in there? I have 1 over cosine, yes? But when I pick u could be anywhere. Its derivative has to actually be in there. I don't know if you guys see the difference. I need to let u equal cosine. What's its derivative? What's the cosine's derivative? Negative sine. Is sine in there? Yes, sine is actually in there. Yes. So I want to let u equal the bottom. And again, what's the 90% of the time what do you let u equal? The part that's stuck. What part is stuck? Cosine. It's stuck on the bottom. Yes? Okay, maybe. Is that cool? So once you rewrite tangent, you got more shit to play with. Do you notice if I can't integrate in Calc 1, the only thing I could do is u sub. That's the only other option we have. So if I think I don't have enough, rewrite it. Give myself more stuff to play with. I got more shit to choose u to be. Maybe. Okay. If you're going to take Calc 2, by the way, the chapter 7 is the first chapter you do. It's chapter 7. And it is full of trig. Not just trig, but trig values, trig identities, trig substitution, which is a method of integration. So between now and then, if you're still shaky on trig, firm that shit up. Okay. There was some trig in 180. You could pass 180 without knowing any trig. You could. You could. Can't pass Calc 2 without knowing any trig. No way. No way in hell. It's everywhere. Is that okay for that problem? Yeah. So if you had cotangent, it would be cosine over sine. You let u equal sine, blah, 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 blah.
I think so, because then you have the derivative of u equal,
Sorry?
sorry, just not very good at like them, those can't projects, what would be the derivative of, I guess the derivative would be like negative sine x.
So on this one, if I let u equal cosine, Yeah, the derivative is negative sign.
and then equal now.
Am I missing something?
So I'm
What am I missing? A negative, a negative sign, negative S-I-G-N. So negative, negative, now I have du, don't I?
What's the derivative of cosecant?
Cosecant? It's not up. I don't have a cosecant, but derivative of cosecant is negative cosecant cotangent. Right? Real quick. What's the worst trig function for derivative of secant? You all agree with me? Because secant's derivative is like magic. Secant creates a tangent. Secant derivative is secant x tangent x. Derivative of cosecant, every co is negative, and there's a symmetry. So if secant is secant x tangent x, cosecant is negative cosecant x cotangent x. Those are symmetric, those are analogous. Makes them much easier to memorize shit. What's the derivative of tangent? Secant squared. What's the derivative of cotangent? Negative cosecant squared. It's a beautiful symmetry.
so that would just doing this substitute
Yeah.
and
Negative sine x dx is du.
so we just have.
And where is your u? Where's the u? Where is it?
Oh, bottom.
On the bottom. So it'll be 1 over u du, which is an easy integral. Yes? Unless you make it hard. What's the integral of 1 over u du? Integral of 1 over u du? ln absolute value. Okay, I like it. So if there's memorization involved in every math class, but if you came in here thinking you could just memorize your way through everything, that's insane. You have got to develop things to look for. What is this problem trying to tell me? Problems try to speak to you. They try to say, hey, look at this shit, do something. If you can't just take the, so if I say, what's the integral of secant squared x? There's no thought there. It's just an antiderivative, just the backwards. Just go, well, tangent's derivative is that, so the integral of that is tangent. Okay, I'm done. Plus e, right? If you have an integral that's got more going on, that's just not directly, then I think you said, right? That's kind of like the process to go through. And then Calc 2, the first 5 sections of Calc 2, they each give you a new method of integration. So they just gotta be ready. Right now we have 2. Calc 2, you're gonna have 7 total by the end of section 7.5. Then you have to know when to use which. Okay. Yeah, Jeff, thank you. I feel so good now. I'm sorry. This is the reality. What's the hardest part about any math class? Very often students understand a process, they just don't know when to do it. Do you agree? Now sometimes students don't understand the process. But the bigger issue, the more general issue is always, when do I do this? When do I do use sub, Jeff? I don't know. When you have to, when you can't do it any other way. Okay. So even in Calc 2, what I tell students is rule out U sub before you use a funkier method. Because U sub will be relatively easy compared to some of the other stuff you're gonna learn in Calc 2. I'm doing nothing but making you feel excited about that in Calc 2. Sorry. Yeah, who knew Calc 2 would get harder than Calc 1? Who knew, Jeff? Right. So what do you guys want to focus on next? Are there more specific questions? I may have general questions. I can make up a bunch of lightning round problems related to an idea. Yes?
Can we take a look at 9B on the practice line?
Yeah. Does anyone, wait, before I finish that question.
It's also, I think it's also useful.
Here it is. Anybody need a copy of the practice final? Anyone? Anyone? Is everybody? Everybody? Okay. That was really weird. Which problem was it? Did somebody just ask me a question?
9B.
9B. Okay. Oh.
Wait, we on the practice?
It's all right.
They mean on the practice?
Practice final? Yes. Okay. Even if you, all right, did anybody try something here? Has anyone looked at this problem yet besides the person asking me the question? And the person asked me the question, did you try anything yet? Who asked me about this one? I forgot already,
I
yes.
just went.
You're like, you're weird. I love it.
Wait, I don't know.
Hmm?
I was sorry, I got confused for a second because I realized it's not sin, it's SLN.
Oh, yeah.
I don't know why you wrote it like that.
Sin squared. Yes.
When I look at this, I wanna separate them. Can I do 1 over s times 1 over natural log of s squared?
Inside the interval, sure.
Yes.
You can't break the interval up cross multiplication, but you can certainly do that. Yeah, hell yeah. Alright. There is something you could do first. Well, let me just ask you this. Based on discussions we've had today, what are you gonna let u equal? Yeah, so try it. And again, not just ln, but it's ln of s squared.
So du is 2. Over s.
So of course, what rule do they have to use? Chain. Chain. Trying to remember my chain. So it's the derivative of ln stuff is 1 over
Stuff.
stuff times derivative of stuff. What can you do right off the bat here?
Take away s.
Yeah, 1s dies a horrible death. No, just a real quick side note. Did anybody notice you could actually simplify this?
Yeah.
Can't that 2 come down? And you could pull it out? Does it really make that big of a difference? No, as long as you do this derivative correctly. But if you simplify and you take the 2 out, this derivative becomes beautifully easy. So what is the one thing I've said the most? If you're about to do calculus to a function, simplify it first. Yes. If you don't notice it, maybe it's still doable, but maybe simplification makes it possible, maybe simplification makes it easier. I don't know. But this is not too bad, as long as you take the derivative correctly. Do you have what you need for du? No, what am I missing? A 2.
Yeah.
So we're screwed.
Put it on the outside.
I like put it on the outside and catch you on the flip side. So now I got 2 over s ds. And what is that? What's 2 over s ds?
Do you?
Du. You guys all cool with that? You see, that is du. That is du. 2 over s ds is du. What's ln of s squared? What's ln of s squared? U. And now that's an easy interval. Right? And that's not even an easy for you to say, Jeff, that is an easy interval, end of story. Now the answer is going to involve the natural log of the natural log. That's kind of a gross function. I don't care because I'm done. Done. I don't have to do anything with it. Just got to write it down and go home. comments about this problem? Obviously, I'm not done. You guys can finish that up. You said number 7 on the practice one? Okay. Oh, yeah. This one? Oh, shit. Come back to me. Okay, go away. Oh, you're staying? Good. What kind of problem is this? Minimize, which is also known as optimization, which involves what 2 things for me to find? What they
Area.
tell me and what they ask me, yes? What do they tell me? What do they ask me? And before I do any of that, I can draw a picture. Right? Anytime you have a geometric shape, you can draw a picture, you can label it, makes it easy to keep track of what's going on. So I have a garden to be surrounded on 3 sides by a brick wall. There's all these wolves that come and try to blow down. And on the remaining side by less expensive fence. I don't know what's happening in this situation, but that's just the way it is. Okay. Can you draw that picture and pick variables appropriate? So it's totally up to you what letters you use. I don't care. I don't care. You could even use a happy face. You could have D happy face. You could have happy face prime. I don't give a shit. I'm silly. I'm going to call this YX. Now, the more you understand, well, first off, just what do they tell us?
We have 3 of one and 1 of.
Yeah, that's related to what they ask us, though, correct?
Okay.
They ask us about the cost. I'm not there yet. What do they just straight up tell me? Area is 108. Can you write the formula for that?
Area is X times Y.
What's the formula for area based on what I've chosen here? Don't overthink it. Nothing else comes into play. No, there's no money involved here yet, right? This is not the cost formula yet. This is the area formula.
X times Y.
XY equals 108. Yeah. That's the problem. Well, I don't blame you necessarily, because you know these have to mix at some point, but the tell us and ask us are almost always kind of independent from each other, and then they come together. So what they tell me has nothing to do with money. What they ask me about is the cost, and then I gotta take in the money information they give me. Yes? So is everybody cool with this so far? So my entire first thing I worry about, what do they tell us, what's related to that? I don't have to worry about the money, I don't have to worry about any of that shit. Now they ask us about the cost. I have to construct the cost formula. I think somebody started to say this. What's special about one side?
It's only got 1.
Cheaper. Now this is where people kind of trip up. Which side is the cheapest side? Do we know? Should it matter then? It don't matter worth shit. So I need you to understand. If that's the cheapest side and I get X is 7, if somebody else chose that to be the cheapest side, they would get Y is 7. Do you understand? That's how math works. Is my rectangle, could X be smaller than Y at the end of my work? Of course it could. Did I know shit about which one's bigger when I drew this? No, this is just a temporary visual anchor. So when I do the math, depending on who I call my cheapest side, that's going to kind of tell me which side's going to be smallest, correct? Or biggest. In this case, whatever the cheapest side is probably going to be the longer side. If I'm trying to minimize my cost, does that make sense? Now, do you have to have any of this in your head? No, but if some of you guys put it in your head, I'm trying to show you why you don't need it there. So what do I call, it doesn't matter, does it? Is it the top X? Is it the left Y? Is it the bottom X? Is it the right Y? Who gives a shit? You tell me. First thing I hear.
X.
Which X? Top X, okay. So we're gonna make this one the cheapest. So what is my cost formula? Don't overthink it. How much does that side cost total?
$15.
$50 per foot. How long is it? Tell me exactly how long this side is. X feet long. So how much total money is it? 15x. Yes? 15x plus 30x is? Holy shit. Now look at my y's. These are each going to be how much money? 30, because we already identified the cheapest side, the other three, the more expensive sides. 30y, 30y.
30y squared?
No, I'm not multiplying, I'm adding them.
Oh, 60y.
Yeah. Thank the gods we don't multiply when we're figuring out total cost of things. Holy shit. We're gonna buy a car and a house, it's gonna cost me about $2.7 trillion. No, don't multiply those costs. So, I tried it. It's already hard enough to do word problems, period. In these kind of problems, there are two kind of separate word problems. So that's why I try to get you guys, and some of my colleagues use, like I said, you might have heard this from tutors, constraint function, objective function. If you haven't, fantastic. And to me, the words don't matter. Tell me, ask me makes way more sense. And that's all that matters right now is, do you see how this problem breaks up? Can I use what they tell us in what they ask us? How do I do that?
Solve for one variable.
Yeah, solve for a variable. Which one? I don't care, shit. I don't care. Solve for one of the letters, replace that one, and then do what? What do I eventually want to do with the cost function in order to find the minimum? A derivative. So once you solve a letter, plug it in, derivative. Find the critical numbers. Yes.
Can you explain again how you got 45 and 60?
Oh, sure. So we said this one is $15 per square foot and all the other ones are 30. Yes?
Yes.
So this is 15x total cost. This is 30x total cost. 45x total cost.
I see.
30y, 30y, 60y. Yeah. Just make sure if you do this, don't take these numbers into account here. Then things get really weird. You're really tiny little gardens.
I can plant one flower.
It's not gonna do good. Maybe? No, screw you. Can you at least see how to sell it? Can you see the physical, two different physical things? It sounds area. So they tell me I can focus completely on area. I mean, that's what they tell us. And then they ask us about cost. I can focus completely on cost then. When I'm done with that, then I see how to merge those two together. Take one, solve for the letter, plug it into the other one. Yes?
Can you solve for the variables using the area function and you put that into the cost?
Yes, I'll take, because I need to find the minimum cost, so I want to be able to take the derivative of cost. I want to take, like if I can solve this for y, I can then plug that in place of y here. Is that cool? I just replaced y with this, is that cool? Yes? Y is 108 divided by x. Replace y with 108 divided by x. I can multiply this shit, bring this up, take a derivative. Critical numbers. So, number 7 is just the, like if I give you a function and I say find the maxes and mins, could you do that? Is that a difficult thing to do now? No. Derivative, critical numbers, first derivative test, or second if you want, right? Blah, blah, blah. This is exactly that problem. It's just saying, we're not going to give you the full function. You have to make it yourself. So this entire first step is just creating the function we can then analyze. We have to create the function. That's why word problems suck. We have to make our own function. Now I want to talk about student math real quick. Student math says, well, he's only going to put one of those problems on there. I'm not going to worry about it. I'll try something to get some points, but I'm not going to worry about it. I mean, that's your own personal choice to make. So I'm going to put 4 other problems on. No, I'm just kidding. It took a little too long for me to do that. I don't know. Normally, do you have more time for a final? You know? No, it's normal class time. Normal class time.
You don't know that we need more time.
I don't know.
I mean, if it's the same size as, maybe.
Well, you're thinking backwards. Since we don't get more time, it's gonna be about the same size as the normal test.
Oh, yeah.
Yeah. So can I possibly put everything on it?
No.
No. So exactly what am I gonna leave off? Well, you find out when you get yours.
I mean, I'm trying to figure out probably like, basic stuff that we.
You can make guesses and
I mean, the stuff that like everything else depends on anyway, so.
Yes.
Like, how to deal with your
I mean-
derivative, like.
again, if you still have trouble with some derivatives, that's your immediate focus.
Like if you
Because integration comes from understanding derivatives. Doing a problem like this is understanding how to do derivatives. So if you still have trouble with any derivative rules or derivative modes, then you want to focus on that first, and then move to integration. Yeah.
For D, 2D, on the practice, it's just that function, it says, I don't know how to pronounce that correctly.
This here?
Yeah,
Oh,
you just treat it the same way as a regular trig function.
here's the funny thing. I could put shit here you've never ever seen. Ever seen.
It's just
And
going
it
away.
wouldn't matter. It wouldn't really matter.
It's just a constant.
No. Why wouldn't it matter? How do I take the derivative? Because that's what I'm asking for there, right? How do I take the derivative? What's the first level of taking the derivative of this? Put whatever's there, whatever the variable part, and of course I have to flip these if the variable is on top, but it is. Take whatever this variable piece is, shove it in. So I'm going to try this one more time. It only makes sense that this function should not change form. I'm going to plug some shit into it, but it cannot change form because the derivative of an antiderivative should cancel. So you shouldn't be trying to integrate t and quotient whatever. No, you should be trying to take the derivatives. Yes? No? Do you want to do this by hand? Do you want to do this? Do you want to do the cube root of that by hand? Anybody? I'm curious about you. What about this? You want to do this by hand? All day. All right. So it doesn't matter that I don't know what the cube root of this is when I'm undoing the cube root anyway. No. Doesn't matter that I don't know what this function is when I'm undoing what's happening to it. No. In this specific instance, why can't I just plug the x squared in and be done?
Because it's not an x.
Because the inside function is more than just x. That's chain rule. Now this is one of the funkiest functions we've ever seen. What's inside of the cosh? T. What's inside of the e on this problem? 2t minus 5t. Yes, the inside is easily identifiable. What's inside of this function? X squared. Because that is its inside. It is very trippy function. Very trippy. But if that piece is more than just x, chain rule. Yeah.
There's an X at the bottom.
Then you'd have to break it up.
Well, not maybe like on the.
Oh, if the top was negative 2.
Yeah.
Okay.
Would you be okay with us not flipping it and just putting
That's fine. Basically, if you don't flip it, then you make the thing negative, or you make the thing negative to flip it, and then it's the same answer at the end. Either way, it's got to introduce the negative. Yeah.
So you mentioned two x's, and you're saying we gotta separate it. What our other limit be?
Oh. Okay. This is where things get really trippy. I can't remember if I assigned one like this in the homework, but just to show you in general, if I had this, oh Jesus, my poor little pen is finally giving up. Here we go. What was I doing? Oh, so if I had, here, let me. Does anyone know what that is? Cool! Don't matter, does it? Alright. None of us know what the shit that is. Well, I do, but. Ooh, give a shit. Oh. Alright. You guys know well more about me than all kinds of stuff. How do I take this guy's derivative? Well, here's the issue. Does anyone see the really big issue here? What's the form for a function, an integral function I can do the derivative of? Integral a to x. A is a constant. So what's missing? I don't have a constant anywhere. So here's what we do. There. So real quick, if I'm going from x to x squared, do y'all agree with me as long as that's not 0 or 1, there are numbers between these two, yes? So I just pick a number between, c. C is between. So I go from x, so I just pick a number between. C. So I go from x to c, and then I go from c to x squared. So this guy's derivative would be the derivative of this, where I gotta turn these around or just make it negative. And then this one I just shove it in and do chain rule. I can't remember off the top of my head if there's one in the homework like that. But some of you guys are like, I don't know, man. I don't do homework. All right, I noticed. Well, you guys do though. Sounds like you guys saw one like that. Yes.
Can we please go over 8b on the practice final?
Oh, so what's the first thing you try on 8B?
Plugging it in.
Plug it in, and when you plug it in, what do you get? You don't get 0. I wish you got 0. If you got 0, you're done. Yeah, you get 0 over 0. Why does that suck? Indeterminate, which literally means we are unable to determine the answer. So, what do I do?
You just have to or pick a number.
Yeah, you go to the hospital. Yeah. No, I'm sorry. You use L'Hopital. Yes. Because we have a ratio that's in indeterminate form. That's exactly when L'Hopital's rule works. It's all about who's getting there quicker. If the top's getting to 0 quicker, then the limit is 0. If the bottom's getting to 0 quicker, then the limit's infinity. If they're both getting to 0 at roughly the same pace, then the limit could be any finite number. So the answer is somewhere between 0 and infinity. But L'Hopital's rule helps us narrow that down just a tad. Yeah, so then there's some exciting derivatives that you have to do. On the top, what rule do you have to use? Is the inside more than just x? Yep, you have to use chain rule. You guys with me? Thankfully, I don't think a lot of you guys are doing L'Hopital's and doing like quotient rule. Can you imagine trying to do quotient rule? That's not the point. I'm not taking the derivative of this function. I'm taking the ratio of the derivatives of the top and bottom. So it is so not quotient rule. I'm applying a theoretical idea that L'Hopital came up with.
And then for 8C, for natural log, I know we changed one to 1 over.
Yep.
Is it 1 over x minus 8? And then
That's what I would do.
put natural log on top.
That's what I would do. I would not want to do 1 over natural log on the bottom because natural log is already gross. I don't want to make it
Gross.
on the bottom. Yeah. Why do you have to do that in part C? It's indeterminate. It's 0 times negative infinity, which is indeterminate. But L'Hopital's requires a ratio, so that's why I have to force one of them. Yeah. A lot of mathematics is about form. Yes? If it's in this form, we do this thing. Does anyone have to take, there's a course called differential equations. Is anybody currently in that direction?
Yeah.
You have to take it. Anybody else know if they have to take that? That class is what I just said on steroids. It's, if it's in this form, you do this stuff. If it's in this form, you do this stuff. If it's in this form, so it's very recipe-ish. Our top 2 classes are completely different. Diffie Q is very recipe-ish. Linear algebra is like, I describe it like this. Wow. It's theorems and proofs, and it's lovely, and it's awesome, and that kicks ass. But anyway, I'm sorry. Let's talk about this class. Is that okay with 8C? You have to force the x minus 8 to become 1 over x minus 8 on the bottom, so you have a ratio so that L'Hopital's can do his job.
Sorry, you force x minus e. Sorry.
Rewrite x minus 8 as on the bottom 1 over x minus 8.
Oh, so you just divide, you just remove it, you just divide by x minus 8, put on the bottom.
Hell no, I can't take multiplication and make it become division.
Yeah, I don't.
That's not what I'm saying.
By
Are you guys cool with the fact that 2 is equal to 1 over 1/2?
oh, yeah.
Okay, so then x minus 8 is equal to 1 over x minus 8. So if I have x minus 8 times natural log of x minus 8, I can make this become natural log of x minus 8 over 1 over x minus 8. Or if you like, that. Because the negative power just means it don't like it there, it wants to be on the other side. That's a parenthesis, by the way, not an L. Oh well. Pew, pew, pew.
Oh, because it's still multiplication, right?
Did I send you guys an email about Math 082? Yes? Okay, thank you. 082 is like a support course for 280 that you could take if you're going to take 280. While I'm thinking about it, here, I'll give you guys the answer key, but all of these, therefore, based on what I just said earlier, all of these will not be on there except maybe as bonus problems. They're from 6.2 and 6.3.
Oh, what?
Yeah, if you were all the questions that are incorrect, I'll return it. Yeah. Sure. I didn't finish number 6, for example, just because I got tired. But, good old implicit differentiation. Remember that? Oh, So you take the derivative of blah, 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 blah. And then I would just move this way, and I would move this way. Get all my dy dx stuff together. Factor dy dx out and just divide. It's just very brute force after this. Get all your dy dx stuff on one side. Get all your non-dy dx stuff on the other side. Factor dy dx out. Divide by all the shit it's with. That's how you get dy dx by itself. Very brute force.
Sorry, so you just basically like get DX by itself and just get it all inside it.
Yeah, so if I do this, I'll get 1/2 y negative 1/2 dy dx minus 2 secant y tangent y dy dx minus 3x dy dx equals 3y plus 1/x. So if I just add the 3y over and subtract the 2 secant y tangent y over, I got all my dy dx stuff together on one side, all my non-dy dx. Now I can just factor a dy dx out and then divide by all the other shit to get dy dx by itself. It is, like I said, do you guys see what I mean by brute force? There's nothing creative about this. It's just get all the stuff, factor it out, divide. It is brute force.
Oh,
Very algebra. Algebra is just brute force with mathematical manipulation. I also said we could do this graph together if you want. Just because I went right out of the way. I didn't want to do a whole other piece of paper. So it's up to you. You can do that.
Can we go to number 5?
Yeah. Oh yeah. Okay. I don't think I gave it to you here, but obviously on the test, if I would give you the volume formula for a cone, does anyone happen to remember the volume formula for a cone?
1/3 pi r squared h.
Somebody remember. So I would give that to you. It would be sitting there for you. What's a good first step here?
Find
Drop H.
dvdt.
Oh, and then
dvdt.
Yeah. Identify everything I tell you in symbols. Drawing the picture probably should be first because that's where you set up variables. And that will inform you as to what symbols you use for the numbers I give you. So everybody kind of with. So for example, real quick, we know what variable I'm going to use for this. What is dv dt? Do I give you that? Or is that what I'm asking?
That's what you're asking.
I gave it to you. Didn't I give you dv dt? What is dv dt?
Oh,
2! Yeah, the units on it.
we're asking d over d.
You guys see that? I'm filling it with water. I get a lot of shit for the way I say water. You guys hear it? Okay. So you fill it with water, so that's going to be the volume of it. So dv dt is changing at a rate of 2 cubic centimeters per second. If you weren't sure what this was, how can you tell? It's freaking cubic centimeters, which is volume per second, which is dv dt. Now when you draw this cone, you don't have to draw 3D, you can actually just draw the triangle like you're looking at the cone straight on from the side, correct? I know the dimensions of the cup. 10 centimeters by radius of 3, yes? But what's more important than that for my problem? What do I need to identify?
5 centimeters.
What's happening in this problem? Is the cup changing at all? No. What's changing? Of what? The volume of the cup isn't changing.
The volume of the water.
Yes, so what else should I draw in this picture? Water. I should draw where the water is. water. And then what's this?
5. 5
No, careful. No. When will 5 centimeters come into play?
D over
The very end. At the very end, I'm going to do that. I'm going to plug in
Into
5.
a
Is the water always 5 centimeters
No.
deep? No, because what am I doing? Filling it up. So at some point, it hits 5. And if I kept going, it'll go past that. But I'm taking a snapshot at 5. When do I use that information? At the end. If I put it in too early, my derivatives will be 0, and I don't know shit. We're all living in caves, sucking our thumbs. Going, could life be better? I don't know. It might be an overstatement. So, what's this?
The height of the water.
Sure, so what is it? H. Kick ass. And what's this? That's insane. So what's the volume of the water? You do it. I told you this. What's the formula for the volume of a cone?
1/3 pi r squared times.
Which is exactly the water, right? Because of r is radius, h is height. Yes? Now what's wrong with that formula? Too many damn variables, right? In fact, if I take its derivative, not only would I have to use product rule, but I'm going to get dr dt. Do I give a shit about dr dt? What do I care about? The height. Because they give me a height and they ask me for how quickly the depth of the water level is rising. That's height. I don't care about r. Poor little r. Are you guys, now listen. This is exactly what you should be saying to yourself as you're doing a problem like this. I've got a formula. I want to take its derivative. I've got parts I don't care about and I don't have information about. How do I get rid of them? Is there a relationship between R and H? If you think about it physically, there has to be, because they have to live in this cup. And this cup has physical constraints. How do I get the relationship between R and H? How?
R divided by h. No.
If I draw straight down through the radius edges, then I just make a triangle, 2 triangles, yes? One big one and one small one, yes? They're similar triangles because they share the same angles. Therefore, the radius of one to the height of one is the radius of the other to the height of the other. Similar triangles, proportions. What letter do I want to solve for? No.
R.
This is counterintuitive a little bit. You solve for the letter you don't care about, because then you can replace it, right? I don't care about R, I want to replace it with something with H, because I care about H. So I solve this for R, plug it in. This feels a lot like Tell Me, Ask Me. In fact, it sort of is, but not every problem like back in the section was a Tell Me, Ask Me, so I didn't want to introduce it then.
Multiplied
Maybe.
by h.
Is that what Past Chef did? I really hope so. That guy can be crazy. Oh, look at me go.
Oh, I did
I
it.
don't know. The end got a little. I think I was trying to do stuff in my head. That's never a good idea. We'll see how it came out.
I think I solved for the radius. For 10h.
So you guys see, how do I solve this for R?
Multiply by r.
Multiply by, well, I could cross multiply, but I could just directly multiply by H. Then I take this. I just told myself that R is this, so wherever I see an R in the problem, I can replace it with this. Now I've got a volume that only is dependent on the variable I care about. Why do I care about H? Because I'm given a height, and I'm asked about the change in height. I'm not given a radius, I'm not asked about the radius, I don't care about the radius. Once I plug it in, I clean it up a little bit, and then I take a derivative. Oh, I did. Look at me go. All right. Square it, yes. Whatever the R is, you have to square it. Square everything. The R is, yeah. So right next to this, if you wanted to, Ezekiel, you could just put R squared equals. Square all this shit and then replace R squared with what it is. If you wanted to. Or you plug R in and then you square it and do it all in one fell go. One fell swoop. That's the-
I didn't get an
The
answer.
bonus question, number 4 on the
Can I get an answer key for the?
Oh yeah. You're gonna kick yourself. Number 4 was easy. So you integrate like you always do. You shove an A in. You just shove everything in. You do everything like you normally would. And then you set what you get equal to whatever I said it had equal. You see what I mean? Do the integral like you always would. Just do the integral like you always would. Just when it gets time to plug in the limits, just plug in an A, plug in whatever the hell the other one was. You see what I mean? People try to do stuff with the H early. I don't know what to do with it yet. I know whatever I get from the integral should equal the number I tell you, but I don't know what I get from the integral yet. I gotta get that first.
Can I have an answer for?
Oh, did I not give you one? I suck. I suck. Yeah, bonus number 2 wasn't too bad either. Bonus number 3 depended on you knowing your trig identities, and bonus number 1 was easier than it looks. You're all like, the hell's me out, Jeff.
What about the first one? First bonus question.
Oh yeah, that was the piecewise one, right?
Yeah.
So you integrate from 0 to 1, plus you integrate from 1 to 2. Just a different function takes over. Yeah.
So on this,
Yeah, I was
number
trying to-
8, I would have to put the positive infinity.
Yeah, now you have to figure out which infinity it is.
Okay,
Yeah. And since the top is positive, the bottom is positive.
so I
pop.
had it right. but
Yeah.
Just forgot a step. I'm rewriting it to do hot sauce, I'm gonna keep getting.
Yeah.
I had it right the first time.
Yeah, you can't do L'Hopital's on that one.
Dope. So that one should be really
one extra little thing about your grade sheet. Do you guys remember how much the final is worth?
25%.
Do you remember that it's like 20 or 25%? Like your tests are 50 or 55%. Do you guys remember that? So until the final's taken, I don't know which one's your lowest grade. So whatever your lowest grade is amongst the test averages, quiz averages, and final exam, I'm gonna count for the lower percentage. Do you kind of see what I'm saying? So then at the end, it's gonna come out a little better than the current prediction is. I don't know if you guys are with me on that. So just remember, there's an adjustment at the end based on what your lowest average is. That will make things a little bit better than it might say on the grade sheet. Yeah.
How do we figure out what our grade is in the class after we're all done?
You email me or you wait for the grades to hit self-service.
Oh, so
Yeah. I don't care how much you want me to use grades, I'm not going to. I'm sorry, I don't want to say that. I hate Canvas gradebook stuff. It sucks. It sucks so bad. But yeah, what I'm gonna remind you guys is when you take the final, so just send me an email, whatever. It won't bother me if you send it to me right after the bill of policy. I'm so sorry. No, who cares? I'm not gonna look at it until I'm ready anyway. So you just send me an email and say, whenever you're done, let me know how I did. Thanks, man. Bye. And 3 weeks later, I want like Christmas break to start quick, so probably the next day I'll be able to tell you how you did.
Get all your time off.
Hell yeah. Yes. Oh yeah, that's right. So listen, this is not. This is semi your fault, but not really. If you're on a website, I never, for some reason, I could swear I did, but 5.4 doesn't show up. 5.4 is not there on website. But that is something that I've assigned problems from. So at the end of the day, you're supposed to do your problems. But it's not your fault that I didn't build it. Yes? So I could put it in there if I remember and have it as such credit. You can have it for like a little bonus credit, bonus points, or like just to give it a try. It's more practice. 5.4 is really all about indefinite integration. And some definite intervals, if I remember correctly, but I just forgot to build it. Or forgot to assign it or something, I don't know what happened. But yeah, so I'm not gonna count it against you. And if I remember, I could build it and then you can use it as practice if you want. Yeah.
I am
In 4B from the test, does the three
From test 4?
yes,
4B. Yeah.
does the natural log just cancel itself out?
Did you have the one that was like 4T e to the T?
I had 3 natural log t.
Oh, that one. Yeah. So when you throw an e to the x in, then the natural log of the e cancels.
So we got 3x over 5.
No, because the inside is more than just x. So what rule does it come into play when you take derivatives? Yeah, and then your e to the x cancels.
So these cancel, then that's 3x over 5.
So it comes out nice and.
is it not right to
Wait,
read this?
I would have forgotten.
What's the root?
Oh.
There you go.
I think so.
Cutting it into 4 parts, and taking 5 of them, so it's 5 horsepower. No. Yes.
What I really need to really focus on is these trick functions. It's like all of them that I got wrong is trick functions, trick functions, trick functions, trick functions. This one I just forgot to actually focus. I think I read it.
By the way, guys, just because, a to the 4/3 isn't 8, 2 times 2 times 2? And this says take 4 of the 3 parts that 8 is, so I want to take 4 2, so the answer is 16 of them. I want 4/3 of 8 multiplicatively. 8 is 2 times 2 times 2. I want 4 of those thirds. 2 times 2 times 2 times 2 is 60.
So 8 to the 1/3 would just be 2.
2. I want 1 of the 3. So 8 to the 2/3 would be 4. I want 2 of the 3 parts of 8. Isn't that neat? Sorry. Just because somebody brought fractional powers up. Does this really mean anything for you? No. And yes. So just remind you guys, quiz 1 corrections, you can still turn them in. Most likely, you would get 1 or 2 points. Most likely, you might get enough, but depends on how many points you missed and how much you get right. You get a few points back. And it's gonna help you study for the finals. What the hell?
Can you show that? The 8 to 4/3. My brain is processing.
I'm sorry. Yeah, I put it back over here. What's up, Jace?
I had a question.
So this says take 4 of the 3 parts of 8. 8 has 3 parts that are 2s. I want 4 of those, so I take 4 2s. 60. What?
It's on here.
Oh,
Alright.
oh, so you get the new power. So for example, real quick, if I had x squared, what do you integrate that? Yep.
Go back to the.
Yep. Good. Divided by the new power, right? So new power divided by the new power. You got a new power negative 1/4, you have to divide by the new power, which means multiply by its reciprocal. So your coefficient should get bigger.
Yeah, it's kind of, you know, it's kind of.
Good. You're good?
Yeah,
Okay.
I'm good. I'll see you later.
Okay. I'll see you Wednesday or before. Where's this one? No, I haven't done the journal yet. You can factor the inside. Yeah, and. Oh.
Oh, they say on the test.
Add the 1/3 on the outside.
Bless you. Bless you. solve for DH. Yeah.
And that's what you said.
Oh, I see.
And then at that point, before
Yeah. It looks good.
changing it to you. I
Something like
think
that.
around
I don't know. I get it part of it in my head, which is always
So
conservative.
that's how I roughly figured.
That would be roughly
So if it's split four, there's like here.
two.
Just
Who knows? Oh wait, it should be divided by.
I was separated so that you can see it easier.
Should be 8 divided by 95, like 95 is probably, then that would be
See, the reason why you want to separate it.
0.3
So
something.
that way you can see
What did I
it's
do?
right here, it's right here.
What was
So
this?
it's taking it off and off and off. It might be-
Yeah, 2.3, yeah. Yeah, so, well, that's the one mistake, yeah, the pie should be on the bottom, because you're dividing.
Where I messed up is where I reevaluated and split it in terms of the. No, I did it wrong first, I did it wrong.
Yeah. Yep. What's the derivative of natural log? Yeah. So that could be one thing, like a memory dump you put up in the corner of the test was going to take a look. Natural log of x derivative is 1 over x integral, 1 over x is natural log. So you're always looking for those 1 over w, 1 over x, 1 over y, whatever, that will go to natural log.
So if you're just saying this out,
Yeah, I mean, minus 3L. Absolute value. Hypertext.
So mad about this so I could unload it. But I did better.
Yeah, me too, but.
I got all goofed up somewhere.
Yeah, it was hard to say, there wasn't like any overriding
That's what I'm saying. Where do you-
mistakes. I mean, like here, you kinda integrated part of it. You can never integrate part of a function by itself. And of course, this one, a lot of people have trouble with this one. This one, can you see how it's u sub? Because it's related to this, right?
Uh-huh.
Yeah.
I think
This
I was
guy's-
thinking it was related to Pythagorean
Oh!
identity.
No, it's got the extra tangent, so it's.
Yeah.
But you're right. If I see a square trig, I sometimes think Pythagorean identities. But I got to remember that my derivatives have squared trig. So then,
That's how I messed up, I think, on that one.
no.
It was that
whenever
2B.
they do come back, it's when it's in.
Oh no, I just didn't. Yeah, I just brought that squared down because I forgot it was 10.
Some of those problems had a nice tan.
Right.
So
But-
which one do you choose? What do you do with
But this one's gonna change, we're gonna change what you was, stay the same, so like, so your original, once you change your new limits to in terms of,
Oh, this
like,
one.
you know how our old one was 8 - 3?
Yeah.
And our new one is 1?
Alright, so
That's right.
1 4.
It's no longer this one, because we changed it.
3u.
So as soon as
Okay.
it's changed, then we don't bring
Yeah,
it back.
there you go.
Yeah, so we'll forget.
So then I need to bring the half outside this too. It needs to
The
be
2 just comes out.
So it's out here.
So that one is nice. It's just no. It's a 2. It's a 2. You're thinking backward. If I needed a 2, I'd have to put a 1F. I have a 2.
So it
You're
just
just taking
carries
it out.
down.
It's just a 2.
It's
Okay.
That 2 that's inside, you could take it out. You don't need to create a 2 out of nothing.
Okay.
Then you need a 1/2, and then you're allowed to put a 2.
Okay.
But I have a 2 that I don't want, just take it out. Yeah.